my name is Ziad and it is our first course in FBGA based on Altera. In this video, you will be taken from the very beginning of knowing what is FBGA through all the way up to make and execute your first project. FBGA is a very powerful tool that can do tasks quick and efficient, even quicker than the normal processors. This is the board we will use in our course. We will explain every single part in this in depth in the next videos. But most important to know now is that this is the chip. This is the chip. And this pin connect this chip to the whole board, and even connect it to the outward. Now it is how to make a project. Just follow this flowchart to make your first project. First, create the project. We will use quartus and explain how to make it in a few moments. But first, you should install quartus and model sim from the links in the description. We will make a video tutorial to explain how to install it, so don't worry. Second, define the port you will use. I will put the links to buy the port we used in the description. Then you should create the Verilog file. Verilog basically is a programming language that describes the logic to the chip. We will talk about it in depth in moments. Then you should compile your code, and this compilation step just to check your code for following the Verilog rules or not. Then simulate the program. This step helps you to check the output of your code on software before actually be programmed on the FBGA chip. Then the pin assignment. As I mentioned in the previous slide, the chip is connected to the outer world using pins. So you must clear to the FBGA where you will insert the inputs and where you expect the output, fetter the output. Then fetter and assembler. It actually transforms your logic code into a logic cells connected with roots and connected with pins. It takes your code and translate it to physical logic gates on the FPGA and roots and connect it with the pins you cleared in the pin assignment. And last step to actually program your device. Let's now talk about Verilog in depth. Any Verilog code, no matter how complex, consists of modules. And these modules, no matter how complex, must consist of basic parts. Start module, module name, input output signals, logic body, and end module. Of course, this logic may be sequential or combinatorial. First, telling the compiler you started a module. By this word module, and telling the compiler where would this module end by the word and module here. And you should name your module space the name, which I named it and then input output signal by opening parentheses and write your inputs and outputs by the word input space the input name, comma, input space the input name, comma, input space the input name, comma, until you finish your inputs. Then output space the output name, comma, output space the output name until you finish your output, and then close your parentheses. The arrangements, first inputs and then the outputs, is not necessary in the code, but better to arrange. And don't forget the semicolon in the end of the line. Then the logic body, the word assign is connect the two wires around the equal sign. So the C is connected is a wire connected physically to the output of A ANDed with B. There's a wire connected physically, okay, by the word assign. And by default, inputs and outputs make your input a wire. This is the default. And then semicolon and then end module. This is the logic symbols. This is not, this is and, this is or, there's NAND, NOR, XOR, XNOR. Now, let's make our project. Now, let's make the project. Press New Project Wizard. Click Next. Choose the place of your project. Hit the name of your project. For example, click Next. Click Empty Project. Next. Here, if there is files you would like to enter in your project, skip, click Next. Then choose click here FBGA. This is the name of the port. This is it. Click it and click Next. It is from the family Cyclone IVE. Next. Simulation, we will use ModelSim Altera, and Verilog HDL, and hit Next. Then finish. Oh, it's done. Click Project Navigator here. It starts here in the hierarchy. Of course, if you click, it will give you this error because you must first make your Verilog file. So click File, New, Verilog HDL file. OK. Like we learned, module. The name of module must be as the name of the project. So our project is called demo, so it is demo and capital, just as the project name, open parentheses, semicolon, in parentheses, input E, input B, input أو output C and in module assign C equal E and it with B. Control S, click Control S and click Save. Now click Tasks, compile design, and also maybe from processing start compilation. Wait a few moments. It will may take like a minute, depends on your PC. I compiled the project with 0 errors. Of course there is warnings because I didn't do the bin assignment step yet. Now when I close it and press on demo, double click, it will open this Verilog file. Now from tools, run simulation tools, RTL simulation to simulate our project. Here's it. Click on work this plus on demo, click simulate. Right click and simulate. Right click on any one of these and click add to wave all items in design. Now in simulation, to input an input, click them like this, right click force. I will click this value, click 1, value 0, so it's ending 1 and 0 and I expect it to be 0. Click here, run, it will run for 100 pico and its output is 0 as I expected. Then I will force it to be 1, click again, it become 1 because 1 ended with 1 is 1, and if I forced it to 0, it will be 0. This is the simulation step. Now the bin assignment step. I want to enter A and B from the button on the port. So I will open the Excel sheet that clears the pins of the FBGA and find K1 and K2. K1 and K2. Number 88 and 89. So I will open the bin assignment from assignments, bin planner. For A, location 88, location 89. And for the output, I want the output to be on the lid. So I will search for the lid on the Excel sheet. The lid is 87. So this output would be 87. Now I can close this, and compile my project. after compilation I would burn the code on the FBGA and try it. This is the schematic of the FBGA. The very important point that the LED is by default connected to the voltage, so it is by default on, and the button by default connected to voltage. Okay, so you need to push the button to give 0, and this 0 would give on the LED. Compile, analysis and synthesis is ended, which means there is no problem in the code. Now he will place the code on physical logic gates and roots. Then the assembler is connected to pins, time quest, which estimate the time and the clock and the latency. Now after compilation, click Tools, Programmer, and click Start. Of course, after connect the USB of the FBGA. After done, try. It works. As expected, it is by default off because the buttons gives 1 and the LEDs by default 1, so 1 of the LED. Then you click, then the output of the AND is 0, so the LED is on. Thank you for watching.